Hi, we'll be going through the social media analytics project today, done by Jephtath 1882002G, submission 15 or 16 of August. So basically for the business understanding, we'll be performing text mining on food recipes obtained from various online sources, basically from the cuisines of the three regions India, Italy, and Thailand. So for data understanding, the Microsoft Excel file that was given to us will contain the cuisines from these three regions, and they have 6 columns as such. Where you can see over here, this is a screenshot of the data set. So for our testing and analysis, the 3 regions will be our target variable, and for ingredients, use our input variable representing serial number set as ID, and for preparation method, those are all considered as text. So the settings are also shown here in this screenshot for the data. Moving on, for data preparation, to begin with, we start out with an Excel sheet. Hence, we are using the file import node to import the Excel sheet into our diagram to begin. Next, we'll be adding the data partition node and split the data into 75 for training and 25 for validation, leaving all other parameters as default. You can see the screenshots from here are according to so. Next, we'll be adding the text passing node to the file import node, which will be basically a table editor to give us a ability to modify start, stop lists, synonym lists, multi-word terms. So basically for this project analysis, right, we have kept the multi-word term dictionary as default. Stop list, I'm reusing what we actually used in class for the practicals, which is the AW stop list. And I did not select the option of using the stop list that was given in the student portal for this project. Same thing applies for the synonyms. I actually use the ones that we use in class for auto synonym, and I did not select the option again that was for the one created on our student portal. This is our screenshot of the settings as well as the diagram itself. So moving on, next will be the text filter to the text passing node. So by adding the text filter, basically I've been keeping the settings here as default, basically spelling, frequency. Well, our term weights, I've actually put it as inverse document frequency, because I realized that the data set, there are quite a lot of data inside that for preparation method, which actually is made up of multiple lengthy sentences that form large paragraphs for every single one. So I decided to use inverse document frequency. So these are the screenshots of the settings as follows. Next, text cluster. So basically what we have done is the settings of the text cluster node added to text filter are as such for these 3. Cluster algorithms have been set to expectation maximization. So settings are over here in the screenshot as shown here. So by looking at the results of the text cluster node, this screenshot will show that we actually have derived a total of 7 clusters that are identified out. So over here you can see the descriptive terms of each of the 7 identified clusters. For example, like the first one, you can see taste peppers, pepper fry, pinch, boil, etc. And we have the frequency and their percentage accordingly here. Next, text topic is added to the text cluster node, and I'm keeping all the text topic nodes as a SAS minor default, as you can see over here. Okay, under the interactive text viewer, you're able to see the topics, terms, and documents. So basically, we're also able to see the respective topic weight, row number of documents, frequency for each term. Documents wise, we can also see the document topic weight also. So how we derive this, or basically as we circle on top, we just selected the first sample as just a reference here, whereby the terms powder have this topic weight, and the document for heat oil and non-stick has this particular document topic weight. So when you compare it back to the selected first topic over here, we are comparing against the term cutoff and document cutoff, we can actually interpret as to whether or not the term and the document is assigned to this above topic. When we see whether or not the cutoff value is larger as compared to the cutoff value here. So For modeling wise, we have actually done decision tree modeling in parallel series for this analysis. I've added the metadata accordingly, the metadata node, before I added in the decision tree. And what I did was I actually split that into 9 decision trees for each. 3 for each region: India, Italian, and Thai. And we did a model comparison at the end for each of the 3. So how do we split this up? The settings of the following decision tree nodes are as follows. So over here we have in decision tree India, all know only cluster, SVD, and cluster. Similar to what we did in the practical, basically what I just did was for each of the 3 ones, the difference is, of course the target variable here is Indian, and the rest are no. So the text cluster SVD, we've all set it as no. However, second one we set it as default, and text cluster we set it as yes. For the third one would be all of the text cluster SVD, set it as yes. Text cluster variable set as yes. This is the sample, this is the whole list, the whole screenshot sample of the decision tree settings. Same thing if you look at Italian cuisine, 3 decision trees, all know only cluster, SVD, and cluster. Similar to the practical as we've done. So basically same thing, this time the target variable is Italian, and we've done the same settings accordingly. This is also repeated for the Thai cuisine over here. Same thing for 3 of them as well. So basically over here, 1, 2, 3, this also same thing, 1, 2, 3. So decision tree Thai, decision tree Thai, decision tree Thai. Apologies for this amendment on the fly. And basically what you're going to look at now will be at the bottom, which is the results of model comparison for each cuisine region. So for India cuisine region, noted basically that the models that have the lowest misclassification rate and average square error out of the 3 are actually the only cluster and SVD and cluster. As you can see over here from the misclassification rates, this is the lesser, and the sum of and the actually average square error over here also is the lesser one compared to the decision tree all know. So we have the screenshots of the only cluster as well as the SVD and cluster results. Here, decision tree, this is for SVD cluster. So this will actually be helping us in determining which decision tree to actually use when we are actually looking in terms of this particular analysis for the Indian region. So looking at over here, second one, Italian cuisine region. Similarly, the decision tree for only cluster and SVD and cluster are the ones that have the lowest misclassification rate and average square error out of the 3 decision trees. So similarly, the results and screenshots are as follows. Going to the last part will be basically for the third region, Thai, and same thing also, only cluster, SVD, and cluster, having the lowest misclassification rate and average square error. So basically, to sum things up, these will actually be the guide for us in terms of which decision trees that we want to actually make use of for our analysis in terms of selecting ingredients for the various 3 regions. Okay, and also over here, this is the second deliverable, which is the SAS project stream or the list of screen capture, showing all of my nodes inside SAS minor, which is basically data preparation, text concept, etc. All these are captured here in this image already. So once again, thank you for your time, and this is the end of my presentation.